Hey everyone, and welcome back for another deep dive.
Oh, it's great to be back.
Today we're going to be looking at the history of data engineering.
Ooh, that's a big one.
Yeah, it is. It's going to be a long one.
It is.
Um, and it's something that I think is really important for anyone who works with data today.
For sure, you got to know where you came from to see where you're going, right?
Exactly. And we have a ton of material to get through, articles, research papers,
Yeah.
even some anecdotes about like the early days.
Yeah, we dug deep for this one.
We did. So, I guess let's just jump right in.
Let's do it.
All right. So, imagine a world before computers
Oh my gosh.
where businesses are relying on filing cabinets and paper records.
I can't even fathom that much paper.
I know it's mind-boggling, and trying to find a single piece of information in that chaos must have been a nightmare.
Oh, absolutely. It must have been like finding a needle in a haystack.
Right. And then, forget about trying to analyze any of it or
Yep.
derive insights.
I mean, how could you even begin to do that with just paper and filing cabinets?
I know it's impossible to imagine. But then in the 1970s, something amazing happened.
Okay, what's that?
The relational database was invented.
Ah, yes, the dawn of a new era.
Exactly. And, suddenly data could be organized into these neat little tables with rows and columns.
Like magic.
Right. And, we can thank pioneers like IBM with their System R,
Yeah.
one of the first relational database management systems.
And of course, Oracle, who's still a major player today.
Right, exactly. And these early systems were so important because they laid the foundation for everything that followed.
They did. They really set the stage.
And, one of the biggest things that came out of this era was SQL structured query language.
Oh, yeah. SQL, the universal language of data.
Exactly. It became the standard way to talk to databases, to query them, to manipulate data. And, it really made it so much easier to work with data.
It's like having a common language that everyone can understand.
Right. And then there's another thing that came out of this era that's not as well known, but just as important: ACD transactions.
ACD transactions. Okay, now you're going to have to explain that one for the folks at home.
Yeah, so ACD stands for atomicity, consistency, isolation, and durability.
Okay, I'm listening.
And basically, these four principles ensure that our data stays consistent and reliable even when things go wrong.
Oh, so they're like the safety net for our data.
Exactly. They're like the unsung heroes of the data world, making sure that, our bank accounts don't suddenly get wiped out or, our online orders don't disappear into the ether.
It's amazing to think about all the work that goes on behind the scenes to keep our data safe and sound.
I know, right? We just take it for granted. But it's really thanks to these ACD principles that we can trust the data that we work with.
So true. So these early innovations really revolutionized how we managed and interacted with data. But what happened next?
Well, as you can imagine, the amount of data that businesses were collecting just kept growing and growing.
Yeah, makes sense. More data, more problems, right?
Exactly. And a new challenge emerged: the need to analyze all this historical data for business insights.
Okay, so we've got mountains of data, but how do we actually make sense of it all?
Right. And that's where the story of data warehousing begins.
Ooh, data warehousing, now we're talking.
So in the 1980s, data warehouses emerged as these massive storage spaces dedicated to housing historical data from all sorts of different sources.
It's like building a giant library specifically for business intelligence.
Exactly. And like any good library, data warehouses needed a system for organizing all that information.
Right, you can't just have books scattered all over the place. You need a system for categorizing and shelving them.
Exactly. And that's where two legendary figures come in: Bill Inman and Ralph Kimball.
Ah, yes, the titans of data warehousing.
So Inman was a big proponent of the top-down approach to data warehousing.
Top down, what does that mean?
Well, he envisioned this meticulously organized, enterprise-wide data warehouse that would serve as the single source of truth for the entire organization.
Okay, so it's like creating a master blueprint for all the data in the company.
Exactly. A superstructured approach. Kimball, on the other hand, favored a bottom-up approach.
Bottom up, how is that different?
Well, instead of starting with this grand vision of a single enterprise-wide data warehouse, Kimball advocated for starting with specific business needs and building smaller data marts that could later be integrated into a larger data warehouse, if needed.
So it's a more agile approach, starting small and building up as you go.
Exactly like building a city one neighborhood at a time.
Got it. So two very different approaches to data warehousing.
Right. And they both had their pros and cons, sparked a lot of debate in the data world.
Yeah, I can imagine people getting pretty passionate about their preferred method.
Oh, absolutely. But regardless of which approach you took, one thing was clear: getting data into a usable format for analysis was a major challenge.
Yeah, that makes sense. You can't just dump raw data into a data warehouse and expect it to magically turn into insights.
Right, you need to clean it up, transform it, and load it into the data warehouse in a way that makes sense.
So it's like preparing ingredients before you can cook a delicious meal.
Exactly, and that's where ETL processes come in.
ETL. What's that stand for?
Extract, transform, load.
Okay, so tell me more about these ETL processes.
Well, it's basically the process of taking raw data from all sorts of different sources, cleaning it up, transforming it into a structured format, and then loading it into the data warehouse.
So it's like the cleanup crew for data, making sure everything is tidy and organized before it goes into the data warehouse.
Exactly. They're the unsung heroes of data warehousing, making sure that the data is ready for analysis.
So by the 1990s, data warehousing was becoming a core part of how businesses operated.
Oh yeah, it was really hitting its stride, and platforms like Teradata and IBM DB2 emerged as the heavy hitters.
Those are some big names in the data world.
They were capable of handling these massive data sets and complex analytical workloads.
So they were like the workhorses of data warehousing.
Exactly. And then along came OLAR.
OLAP, fill me in.
So OLAR stands for Online Analytical Processing. And it allowed analysts to explore data in ways that were never possible before they could slice and dice data, drill down into details, and uncover hidden insights.
So it's like having a powerful magnifying glass for your data.
Exactly. And it really opened up a whole new world of possibilities for data analysis.
So things are moving along. We've got data warehouses. We've got OLAP. The future of data is looking bright.
Right. It seemed like we had finally figured it all out.
But there's always isn't there?
But just as we were getting comfortable with this world of structured data in our neatly organized data warehouses, a new wave was about to hit.
Like a tsunami.
Exactly. And that wave was big data.
Big data now. That sounds ominous.
It was, the internet, social media, and the explosion of connected devices were generating data at an unprecedented rate.
Data everywhere.
Everywhere. And traditional systems just couldn't keep up.
It was like trying to drink from a fire hose.
Exactly. The volume was overwhelming, but it wasn't just the amount of data that was a challenge.
What else was there?
The variety.
The variety.
We were no longer dealing solely with this neat, structured data that fit nicely into rows and columns.
Oh, right. Things are getting messy again.
Unstructured data like text images and sensor readings became a major part of the data landscape.
So it's not just numbers anymore.
No, it's everything.
So what do you do when the old ways of doing things no longer work?
Well, you adapt, you innovate, you come up with new solutions. And that's what happened in the world of data engineering.
So tell me what emerged from this big data chaos.
We'll have to save that for the next part.
Oh, come on, you're leaving me hanging.
I know, but trust me, it's worth the wait.
All right. I guess I can hold on a little longer.
But for now, let's take a quick break, and we'll be right back with more on the fascinating history of data engineering.
Sounds good. I'm ready for more. Okay, so spill the beans. What came out of this big data chaos?
Okay, so picture this. You have this massive amount of data coming in from all directions.
Okay, I'm picturing it.
Right, and the old tools and techniques just aren't cutting it.
Right, they're overwhelmed.
They're totally overwhelmed. So what do?
I'm waiting.
You come up with something new, something radical, something that can handle this deluge of information.
I like where this is going.
And that's where Hadoop comes in.
Hadoop. Tell me more.
So Hadoop, with its distributed file system, HDFS, and its MapReduce processing framework, was like building a giant data warehouse out of Lego blocks.
Lego blocks. Interesting analogy.
Yeah, you could just keep adding more blocks as your data grew, distributing the storage and processing across a cluster of machines.
Ah, I see. So it's like a data warehouse that can scale infinitely.
Exactly. It was a revolutionary way to handle the massive scale of big data. And it wasn't just about storage. Hadoop also provided a way to process all that data with its MapReduce framework.
Okay, break that down for me, MapReduce.
So MapReduce is basically a way of breaking down a large problem into smaller chunks, processing those chunks in parallel, and then combining the results.
So it's like divide and conquer for data.
Exactly. It allows you to process massive data sets that would have been impossible to handle with traditional methods.
Brilliant. And what about the variety of data? How did they deal with all that unstructured stuff?
Right. So alongside Hadoop, we saw the rise of NoSQL databases.
NoSQL, what's that all about?
So NoSQL stands for not only SQL.
Okay.
And it's basically a whole category of databases that are designed to handle different types of data than relational databases.
So it's not just tables and rows and columns anymore?
Right. NoSQL databases can handle all sorts of data structures like key-value pairs, documents, graphs, and more.
Wow, so much flexibility.
Exactly. And they're also really good at scaling horizontally, which means you can just keep adding more servers as your data grows.
So they're perfect for big data.
They are. They really are. And some of the most popular NoSQL databases that emerged during this time were MongoDB Cassandra and HBase.
So we've got Hadoop for handling massive data sets and NoSQL databases for handling all sorts of different data structures.
Right, exactly. We're starting to get a handle on this big data thing.
But wait a minute, who's managing all this complexity?
Ah, that's a great question. And it brings us to the rise of a new hero, the data engineer.
The data engineer, a hero indeed.
You know, with the growing complexity of data systems, someone needed to design, build, and maintain all these intricate data pipelines.
Right. Someone needs to make sure the data is flowing smoothly from source to destination.
Exactly. And that's where the data engineer comes in. They became the architects and plumbers of the data world.
I love that analogy, architects and plumbers.
Yeah, they're the ones who ensure that data is ingested, processed, and delivered to the right places at the right time, keeping the entire data ecosystem running smoothly.
It's like being a conductor of a data orchestra, making sure all the instruments are in tune and playing together harmoniously.
Exactly. And just like a conductor needs a good score, data engineers relied on powerful tools to orchestrate their data pipelines.
So what kind of tools are we talking about?
Well, one of the biggest game changers was Apache Spark.
Spark, I've heard of that.
Yeah, Spark revolutionized large-scale data processing with its speed and efficiency.
What made it so fast and efficient?
Well, one of the key innovations was its ability to process data in memory.
In memory, meaning...
Meaning that instead of constantly reading and writing data to disk, Spark could keep the data it was working on in the computer's RAM.
Ah, that makes sense. RAM is much faster than disk.
Exactly. It's like having a supercharged engine for your data pipelines.
Cool. So Spark helps speed up data processing, but what about real-time data?
Ah, good question. That's where Apache Kafka comes in.
Kafka, as in Franz Kafka.
You know, I'm not sure if there's a connection there, but Apache Kafka is a distributed streaming platform.
Okay. And what does that mean exactly?
Well, it basically allows you to process and analyze data as it's being generated in real time.
Wow, so no more waiting around for batch processing.
Exactly. Kafka enabled a whole new world of possibilities for real-time analytics and decision-making.
I can see how that would be incredibly valuable for businesses.
It was a game changer for sure. And then, of course, there were tools like Airflow.
Airflow.
Yeah, Airflow emerged to help automate complex data workflows, making the data engineer's life a little bit easier.
It's like having a personal assistant for your data pipelines.
Exactly. It could schedule and manage tasks, so you didn't have to manually intervene every step of the way.
Awesome. So data engineers have all these great tools at their disposal, but what about the infrastructure? Where was all this data being stored and processed?
That's a great point. And that brings us to the rise of cloud platforms like AWS, Google Cloud, and Azure.
The cloud. It's everywhere these days.
It is, and for good reason. Cloud platforms provide scalable and flexible infrastructure for data storage and processing, removing the burden of managing physical hardware from the data engineers.
So instead of having to buy and maintain their own servers, data engineers could just spin up virtual servers in the cloud as needed.
Exactly. It was like having a giant data center at your fingertips.
That must have been a huge relief for data engineers.
It was a game changer, for sure. It allowed them to focus on what they do best, designing and building data pipelines, without having to worry about the underlying infrastructure.
So we've come a long way from those early days of relational databases and data warehousing.
We have. Big data forced us to rethink everything, and we came up with some pretty amazing solutions.
We did, but the story doesn't end there, does it?
It doesn't. Not by a long shot. In fact, it takes another interesting twist with the emergence of data lakehouses.
Data lakehouses. Okay, now you've got my attention. Tell me more.
Well, you see, we had data warehouses, which were great for structured data, but not so great for unstructured data.
Right.
And we had data lakes, which were great for storing all sorts of data, but not so great for analysis and governance.
Okay, so we have two separate solutions, each with its own strengths and weaknesses.
Right. What if there was a way to combine the best of both worlds?
Now you're talking.
And that's exactly what a data lakehouse is.
A hybrid approach.
It's a hybrid approach that combines the flexibility and scalability of data lakes with the structure and reliability of data warehouses.
So it's like having your cake and eating it too.
Exactly. And it's been a game changer for data management. And there are a number of platforms that are leading the charge in the data lakehouse revolution. Well, you have platforms like Databricks, which is a cloud-based platform that's specifically designed for data lakehouses.
Okay.
And you have open source frameworks like Apache Iceberg and Delta Lake, which provide the building blocks for creating and managing data lakehouses on your own infrastructure.
So there are options for both cloud and on-premise deployments.
Exactly. And even cloud-native solutions like Snowflake and Google BigQuery have embraced the data lakehouse concept, offering their own take on this hybrid approach.
Wow, so it seems like the data lakehouse is really gaining momentum.
It is. It's quickly becoming the go-to solution for modern data management.
And it's easy to see why it offers the best of both worlds.
Exactly. And, amidst all this technological evolution, there are some fundamental database design principles that have remained constant throughout this journey.
Really? Like what?
Well, I'm talking about the yin and yang of database design normalization and denormalization.
Well, yes, the eternal struggle.
Right. They're like two sides of the same coin, both essential but often at odds with each other.
So remind me, what are normalization and denormalization all about?
So normalization is all about organizing data efficiently to minimize redundancy and ensure data integrity. It's like tidying up your house, everything has its place, and there's no unnecessary clutter.
Okay, that makes sense. And what about denormalization?
Well, denormalization is about strategically introducing redundancy into your database designed to improve career performance.
So it's like keeping frequently used items within easy reach, even if it means having duplicates in different parts of your house?
Exactly. It's a trade-off between organization and efficiency.
Interesting. So the choice between normalization and denormalization depends on the specific needs of the system.
Exactly. Sometimes you prioritize data integrity and minimize storage space, while other times you might prioritize faster query performance, even if it means some redundancy.
It's a balancing act.
It is. And, it's fascinating to see how these fundamental concepts still hold true, even with all the advancements in data technology.
It's a testament to the enduring principles of good database design.
Absolutely. And that's something you should always keep in mind as you navigate the world of data, no matter how fancy the tools get. Understanding the basics will always be essential.
Wise words. So where do we go from here?
Well, that's a great question, and one that we'll explore in the next part of our deep dive.
All right, so we've covered a ton of ground here, from those early relational databases to the mind-blowing world of data lakehouses.
We have, and it's been quite a journey.
It has. So as we wrap up our deep dive into the history of data engineering, what are some key takeaways you want to leave our listeners with?
Well, first and foremost, I think it's important to remember that this field is constantly evolving. What's cutting edge today might be obsolete tomorrow.
Absolutely. The only constant is change, especially in the world of data.
Exactly. So the key is to stay adaptable and embrace lifelong learning.
Couldn't agree more. You got to be a perpetual student in this field, always curious, always hungry for knowledge.
And, it's not just about keeping up with the latest technologies. It's about understanding the underlying principles and concepts.
Right. The fundamentals never go out of style, no matter how fancy the tools get.
Exactly. And, beyond the technical stuff, it's important to remember that data engineering is ultimately about solving real-world problems.
That's it. It's about using data to make a positive impact on the world.
Exactly. Whether it's improving healthcare, optimizing business processes, or even fighting climate change, data engineering has the power to make a real difference.
And that's what makes it so exciting. It's not just about bits and bytes. It's about using data to make the world a better place.
And, thinking of exciting, the future of data engineering is absolutely brimming with possibilities.
Oh, yeah. With the rise of AI, machine learning, and the ever-expanding data universe, the demand for skilled data engineers is only going to skyrocket.
It's an incredible time to be in this field.
It is so. Any final words of wisdom for all those aspiring data engineers out there?
I'd say don't be afraid to get your hands dirty, experiment, build things, break things, and learn from your mistakes.
Love it. The best way to learn is by doing. And don't forget to share your knowledge and collaborate with others. The data community is incredibly vibrant and supportive.
So true. We're all in this together, learning and growing and pushing the boundaries of what's possible with data.
And who knows what amazing discoveries await us in the years to come.
It's an exciting time to be a data engineer, that's for sure.
Absolutely. So to all our listeners out there, keep exploring, keep learning, and keep pushing the boundaries of what's possible with data.
Thanks for joining us on this deep dive into the history of data engineering.
Until next time, keep on crunching those numbers.